Hi, thank you. As Guy mentioned, my name is Steve Kirst, and I'm the product manager for Telehandlers for Gehl. And some of the big debate these last few days has been ground engaging versus lift in place. I doubt if we'll solve it here today, but let me give you my 2 cents worth on how I feel the two machines are completely different. First of all, just with your naked eye, here are two machines that are comparable in size. By looking at these two machines, which machine do you think is rated more? Which machine has a greater lift capacity, according to this rating? How many people think this is the bigger machine? How many people think this is the bigger machine? Okay, according to the hands, a vast majority of people thought that this was the bigger machine. Physically looking at it, yes, it is the bigger machine. But according to industry standards, the way it's rated, this is the bigger machine. This machine is rated at 5,000 pounds of lift capacity. This machine is rated at 5,500 pounds of lift capacity. So just the perception of looking at the two machines side by side, there's some confusion. Why is that? Because in our minds, there's a big difference between a ground engaging machine and a lift in place machine. This machine is what I'll refer to as your typical North American lift-in-place machine, which I'll refer to as a single-dimensional machine. And by that I mean that its major task is to lift something up and place it up high, or to pick something up and drop it down low. It's designed to do one thing very, very, very well, and that's lift and place, pick and carry, whatever terms you want to use. So because of that, we rate this machine differently, and it's very good at what it's designed to do. This machine, on the other hand, is designed more as what I'll refer to as a telescopic loader. By that, I'm saying its primary function is to have bucket or ground engaging type attachments on it. So as a result, it's rated differently. It's rated at 5,000 pounds of capacity. So again, now we're trying to clear up some of these confusion issues, but you can see where the differences are. Okay? If you guys could please just face both machines this way. Okay. What is the main purpose of this machine? Again, the main purpose, when engineering sat down and marketing sat down and talked with engineering and said, they put a purpose plan together and they said, this machine is designed for the North American rental market, and it's designed to 95% of the time have forks on it. So we've got to be able to gently pick up a pallet and set it up 19 feet in the air. So the front end of the machine is designed primarily for forks. Can you put buckets on it? Absolutely you can. Is it designed for it? No. Again, it's the difference between the wide receiver and the linebacker that we talked about yesterday. Okay? This machine, the front end on it is designed for quick changing of attachments, but primarily for forks. When you think of forks, you don't really think of impact loads, because you gently take a set of forks and you've got to hit a 3.5-inch opening on a pallet. So the whole idea behind this front end is visibility and precision, so that you can slide the forks into a 2x4 opening, which is 3.5 inches in a pallet. So it's got to be precise, and you've got to have visibility, which is why you've got the narrow front end. Okay? This machine, on the other hand, is designed primarily for bucket type work. So when you take a bucket and you ram it into a frozen pile of dirt, or you're plowing snow with it and you hit a manhole cover with it at 10 miles an hour, or you hit a curb with it at 10 miles an hour, or 15 miles, whatever it happens to be, and that bucket is 7 feet wide on it, and you hit the corner of this bucket at 10 miles an hour, you're going to take the forces in that bucket and cause that bucket to twist. And the first place that all that energy is going to go to is the front end of the machine. So the front end of the machine has got to be different on this machine than it is on that machine. This is a ground engaging machine. As a result, the front end of this machine is quite a bit wider, quite a bit stronger, quite a bit heavier, designed differently. If you look at just the mass of steel that's used, the thickness of the steel here versus the thickness of the steel here. Not saying this one is weak, not saying this one is strong. What I'm saying is it's got to be different. You cannot have the same thing. Wide receiver, linebacker. Both professional athletes, tremendous athletes, get paid big bucks, slightly more than me, but they're completely different athletes. And that's the point we want to drive home. You look at all the mass that's in the front here. When you've got 10,000 pounds of bucket breakout force on this, and you ram a frozen something or other, or a steel something or other, or a concrete curb, whatever it happens to be, all your forces get pushed into the boom in this direction. When you look at this area right here, the size of the pins, the number of shear points in the pin, and you compare that to the pin on this machine, you run your engineering calculations, and the front end of this machine right here is 2.5 times as strong as the front end of this machine. This machine is not designed for impacts because it typically has forks on it, which is a non-impact type of attachment. This one is designed for impacts because you typically have buckets and grapples on it. Okay? Once your forces go through the pin, the next thing it goes through is the gooseneck. You'll notice the gooseneck is a lot heavier, a lot stronger than it is on this machine. This machine is designed for lifting and placing. Once the forces go through the gooseneck, the next thing that has to absorb the forces are the boom. You'll notice this is a formed boom. This is a box boom. Totally different designs. This is 4 pieces of steel welded together. The top and bottom plate are different than the 2 side plates. So again, like I said this morning in the meeting, if you take an I-beam, the strength of an I-beam is how tall the I-beam is, not how wide it is. You stand an I-beam up, it is strong as hell. You lay an I-beam on the side, it's going to bow. Again, how is it designed? That's not saying the I-beam is weak. It's just saying you've used the I-beam in the wrong way. So here you've got tremendous strength in a vertical position because of the side, the type of side plates that you have on it. This machine, designed completely different, it's a tubular boom. So the sides are the same as the top. So the same amount of strength you have in a vertical position you've got in a horizontal position, and also which relates to your torsional opportunities. So they're designed completely different. That's the same, your front boom and your inner boom as well as your outer boom. If we take this opportunity to turn the machines around, if you would, please. Any questions while they're turning the machines? Yes? Sorry? No, slide pads would be yes, they're different, but the same concept. Top and bottom, all the way around front and back. And then raise the booms up. Raise the boom up. Okay. Remember I mentioned when you have a ground engaging bucket or ground engaging machine, the forces go through the bucket into the quick attach, from the quick attach into the gooseneck, from the gooseneck into the boom. Once the forces come through the boom, the next place the forces are applied to is the back of the boom. How is the boom attached to the tractor? Again, this is a lift and place machine. Primarily all the stresses are in one area. You can see how heavy the back end is here. Perfectly designed for its application. You look on the other hand at the way this machine is designed, you'll notice your reinforcing plates are much heavier on the back end. You'll notice the reinforcing plate on the top of the back of the boom is huge on this machine, where it's non-existent on that machine. Does that make this machine weak? Absolutely not. It's not designed for impact loads. This machine is, because it will take impact loads. That's what it's designed to do. If you look at the diameter of the pins that are used, and the length of the pins that are used, and how those pins are then attached to the tractor, completely different on these two machines. Again, it's the wide receiver versus the linebacker. Okay? Wide receivers aren't designed to tackle. Linebackers aren't made for catching passes. Can they do the opposite? Absolutely. But is that what they get paid the big bucks to do? So can you cross-use these in certain applications? Yes, you can. But is that really what it's designed for? No. Harley Davidson. I come out of Milwaukee. Harley Davidson's made in Milwaukee. Harley Davidson motorcycles have trailer hitches on them. Does that mean you can pull a boat with it? Does that mean you can pull a house trailer with it? No. They're designed for small little trailers. Okay? Just because the Harley Davidson's got a trailer hitch on the back of it doesn't mean you're going to pull your boat with it. So again, we got to stay focused. These are compact machines designed for compact markets with compact attachments on them. Okay, last thing fellas, if you want to turn them so I can see the cabs please.